Math morning, or math afternoon, or math night. Depends on when you're watching this video. But this is Mr. Darkus again, coming at you live from Tech Boston. Today we'll be translating verbal phrases, translating English into math. This got me thinking about this summer when I went to Haiti. Before I went, I asked some students how to say, "Thank you for your hospitality. I had a great time here." They told me to say, "Mwen remen shot." I got down there and I started saying that, and everybody was looking at me funny. I still don't know why. I'm going to give you guys some advice right now. You need to listen to the video. Some of you might fall into the trap of listening to music or not putting in your headphones when you're watching the video, but it's really important that you listen to everything I say, because some things that I say I'm not going to write down, and if you're not listening, then you're going to miss it. So it is extremely important that you continue listening to this video. Okay, you should pause this video and write down these words. Great. So we are going to translate these phrases into mathematical operations. We have the four major operations here. We have addition, subtraction, multiplication, and division. We'll start with addition. So we have the sum. That is when you add two numbers together, it's your answer. So find the sum of 5 and 2. You add 5 and 2 together. Plus, you use that interchangeably with add. So 5 plus 2, 12 plus 100, you add those together. The total, that is similar to sum. So you can say find the total of 6 plus 9 plus 12, and you add those together and find the total. More than is also addition. So 5 more than a number is 5 plus x. Increased by, also addition. 100 increased by 50 is 100 plus 50. Now up here we have subtraction. The difference, that is the answer to a subtraction problem. So 100 minus 50, that equals 50. So the difference is 50. The order you say this in matters too. So if I say find the difference of 10 and 8, you have to do 10 first. So the difference of 10 and 8 is 10 minus 8. And that difference equals 2. If I said find the difference of 10 and 8, and you did 8 minus 10, your answer would be negative 2. And so the order of subtraction really matters. Next we have minus, 12 minus 5, that's subtraction. Less than 100, less than a number would be 100 minus x. Decreased by, there's also subtraction. Multiplication, product, that is the answer to a multiplication problem. Times, you use that interchangeably with multiply. So 5 times 12, you can say 5 multiplied by 12. Multiplied by, I don't even know why that's on here. It's pretty obvious, but that's multiplication. Of, this one might not be as obvious. You use this a lot with fractions. So if I said 1/4 of 24, that's 1/4 times 24. So of, you hear that a lot with fractions. Division, we have the quotient, that is the answer of a division problem. After that, we have divided by, divided into. Those are both division. The last one is per. You hear that a lot in real world problems. Miles per hour, gallons per mile. And so that means division. If you have miles per hour, you have the miles divided by the hour. All right, let's translate some phrases into numbers. If you remember, of, that means multiply. So this one we know that we have to multiply 3/4 and a number. When it says a number, we don't know what it is, so we have to use a variable. You could use any letter you want, and this time I'm going to use n. So I can say 3/4 times n. I can also write this 3/4, put parentheses, of n. But in algebra, the way that you see this written is going to be 3/4 n. When you don't see an operation in here or parentheses, it means multiply, and I want you to start writing it like this because most algebra teachers and students write it like this. Next we have 5 less than a number. I know when we have less than, that's going to be subtraction. So 5 less than a number. Alright, so for a number, I'm going to use a variable. I'll use x this time. But my question is, will it be 5 minus x or x minus 5? Take a second, try to think about what it would be. If you thought it was this one, you are correct. Why? Because we have the number and we want 5 less than this number. So whatever number it is, we subtract 5 from that. So this is the right way to write it. This is not. Now we have the quotient of 7 in a number. I'll use g this time. And if you remember quotient, that is division. And I'm going to write it like this. 7 divided by g. That's a g. It looks like a 9. Let me make it look like a g. That's a g. Why do I do it as a division symbol? Most people in algebra and higher math than that, when you have divide, you write it as a division symbol. You could write it like this, the quotient of 7 and the number. Again, that's a g. But this is the way mathematicians prefer. Lastly, we have the sum of a number and 8. Sum, that's addition. A number, that's a variable. I'll use f. So sum is add the sum of a number and 8. If you remember, I studied abroad in Spain, and before I went, I asked some of my Spanish-speaking friends to say, where is the bathroom? They told me to say, todos de mis amigos son gatos. When I got there, I said that, and for some reason, people were looking at me funny. I still don't know why. So now we're going to go over some definitions and conversions. I want you to pause this video, copy these down, and then hit play again. Okay, great. So the first definition is rate. This is a fraction that compares two quantities measured in different units. All right, in fraction, that's going to be divided. So you often hear this when you're driving a car. You have maybe 8 miles per 1 gallon. You can compare different cars' fuel efficiency with this. You might also hear something like 240 meters for 3 seconds. These are both rates. Rates are great, but unit rates are even better. This is a rate when the denominator of the fraction is 1. Right here is already a unit rate because we have 1 in the denominator, the bottom of the fraction. These are good because we can easily convert them to different rates. So if I wanted to know how many miles I can get with 2 gallons, well, I know 2, that's 1 times 2. So 8 times 2 is 16. So 16 miles per every 2 gallons. This one over here is not a unit rate, but I can turn this into a unit rate by simplifying the fraction. I want the bottom to be 1, so I divide that by 3. 3 divided by 3 is 1, so I have 1 second on the bottom. 240 divided by 3, that's going to be 80 meters. So 240 meters per 3 seconds is the same as 80 meters per 1 second. Now we're going to do this problem down here and these conversions on the top right to find a unit rate. This is going to be more complicated than the other ones, but we're going to work through this together. So it says, a roller coaster travels 240 miles in 2 hours. Find the unit rate in feet per second. So I know my answer should be in feet per second. So I'm going to write that over here. I'm starting off with 240 miles for 2 hours. I'll write the whole thing in miles. So my goal, that's a fraction bar, is to change this into feet per second. I can do that by changing these units. The great thing about math that helps you change units is that number 1 is a fantastic number. Why is it so great? Let me tell you why. You can take any number in the world, I'll say 200, and you divide it by the same number, 200, and it equals 1. You can also take 1 and multiply it by any number, let me say 72, and it equals that number, 72. I can use these properties to change units, because if I multiply this over here by the same number on the top and the bottom of a fraction, it doesn't change the value. That way I can cancel units. So if I want to cancel mile and hours to get the feet per second, I just have to look at my chart and I see 1 mile equals 5,280 feet. If I want to cancel the miles, I'm going to multiply it by a new fraction and I'll put miles on the bottom. That conversion over here was 1 mile for 5,280 feet. When I have a mile on the top in the numerator and a mile on the bottom in the denominator, I can cancel them. Now I have feet in hours. Over here I have feet per second. So feet, I can leave it like that, but I need to change hours into second. So if I go back up to my conversion chart, alright, I want to get rid of hours. I see 1 hour equals 60 minutes. So 1 hour is 60 minutes. If hours is on the bottom, I want to put it on the top. 1 hour over 60 minutes. Now, hour, gone. This hour, gone. Now I have feet in minute. Well, that's closer, but I still don't have seconds. So let me go back up to my conversion chart. 1 minute equals 60 seconds. I'll use that one. So on the top, I will put 1 minute because the minutes will cancel. And that was for 60 seconds. So minutes gone, minute bye-bye. Now I have feet and second. That's what I have over here. To turn this into feet per second, I just have to multiply all the numbers on the top together. So I do 240 times 5,280 times 1 times 1. And on the bottom, I do 2 times 1 times 60 times 60. Let me pause this and calculate. When I multiply all these numbers together, the numerator becomes, and it's really big, so I'm going to try to write it on an angle, 1,267,200 feet. And let me do the seconds. We have 2 times 1 is 2. 2 times 60 is 120. Or 120 times 60. What is that? 120 times 60. 7,200. Alright, I'm going to write this over here just so it looks a little bit cleaner. I'll draw a little arrow. We have 1,267,200 feet per 7,260 seconds. You might be saying, hey, Mr. Durkis, this isn't the unit rate. That's what we're trying to find. Well, great. We're going to find that now. So how do I convert this feet per second into a unit rate? I want the second to be on the second to be 1 second. I can simplify this fraction. So I'll divide 1,267,200 by 7,200. And that equals 176 feet for 1 second. So this roller coaster, it travels 240 miles in 2 hours. That's the same as going 176 feet in 1 second. So now I want you to pause the video, copy down these definitions. Great. So an equation, this is a mathematical sentence formed by placing the symbol equals between two expressions. So in the last video, you learned that an expression is something like 2x plus 5. That's not an equation. An equation has an equal sign, and you put another expression on the other side. So maybe x minus 12. When you have two expressions and an equal sign between them, that's how you get an equation. And remember this, equation has an equal sign. Equation, equal. The next one, inequality. This is a mathematical sentence formed by placing one of the symbols less than or equal to, greater than, or greater than or equal to between two expressions. You could also use not equal. An example of this, you can say 1 is less than 5, right? 5 is the bigger number. The symbol always opens to the bigger number. I like to think it's hungry, it's a mouth, it wants to eat the bigger number. And this can also be written 5 is greater than 1. This is the same exact thing. If I could even read it this way: 1 is less than 5, or 1 is less than 5. Again, I want you to pause this video, copy down these words. Great. So when you're writing an equation from words, if you have an equal, you have is equal to, the same as, those are going to be equals. Less than, another way to say that is fewer than, that is the less than symbol. This one freaks people out over here. When you have less than or equal to, some other words are at most, no more than. So if I said I want at most 20 students in my class, that means I don't want to have more than 20, right? So if I have 20, the number of students has to be less than 20, or it could be 20. So if I say at most or no more than 20, it's actually less than. On the other hand, we have is greater than, more than. That one's pretty obvious. This one also freaks people out over here. Greater than or equal to. If I say at least, no less than. So if I say I want no less than 100 A's. No less than 100 A's. That means I can have 100 or more, but no less. So this number has to be greater than or equal to 100. You might run into some problems that say, check to see if a number is a solution to an equation or inequality, right? So this is how we do it. You substitute a number for the variable in an equation or inequality to see if the result is true. So check to see if 8 is a solution to the following. So I have 9g, and we're going to evaluate. So 9, remember, if there's no symbol, that means multiply. 9 times 8 minus 4 equals 70. I simplify 9 times 8, that's 72, minus 4 equals 70. 72 minus 4 is 68. Does 68 equal 70? No, it has to be exactly the same when it's equals. So this one is false. Look at the sad face. This one over here, same thing. 4y plus 8 is greater than 10. 4, I evaluate, substitute. 4 times 8 plus 8 is greater than 10. 4 times 8 is 32 plus 8 is greater than 10. 32 plus 8, 40 is greater than 10. 10. Is 40 greater than 10? Yes, it is. So this one is true. Happy face. Now we're going to use some mental math to solve these equations really quick. So we have 6 plus y equals 14. 6 plus what number equals 14? I don't know. How about 6 plus 8 equals 14, right? 6 plus 8 equals 14. This is going to be the beginnings of solving equations. They'll get more complex, but right now we're kind of doing these in our head. The next one, what number times 9 is 27? If I wrote that like this, 9b, that's the variable, equals 27. You see times, we don't see the operation, but it's multiplied because the coefficient is next to the variable. Well, 9 times what equals 27? 9 times 3 equals 27. Again, this is the beginning of solving equations. We'll get a little trickier later on. Now we're going to try some of these on our own. Pause this video, try them out. I started it for you. Okay, great. So you look back, got a conversion. We want to change this 30 miles for 2 hours into the unit rate. I know 1 mile, that is the same as 5,280 feet. Now this miles over here cancels with this mile. 1 hour, that's the same as 60 minutes. Wonderful. So now this hour cancels with this hour. 1 minute, that's the same as 60 seconds. So now this minute cancels with this minute, and I'm left with feet and seconds. Forgot the C. When I multiply 30 times 5,280 times 1 times 1, I get 154,400. And when I multiply 2 times 1 times 60 times 60, I get 7,200. I want this in the unit rate, so I divide that out, and I get 22 feet per second. Now I want to check to see if 3 is a solution to 5z minus 8 is less than 20. So when I evaluate, I substituted the 3 for the z. So 5 times 3 is 15. I have 15 minus 8 is 7. 7 is less than 20, so that is true. That's all for right now. You can move on to the practice problems. Good luck. Keep going. You got this. Dirkus out.